Alright guys, I am so sorry that the live meeting didn't work very well. This is what I'm going to do to make up for it. I'm going to work all the problems that those of you who attended the meeting requested. And then afterwards, if you watch this video and you have more questions, you can send those questions to me and I'll make another video, okay? Alright, so the first question was on page 6. Page 6 has a question about Max. Max travels to see his brother's family by car. He drives 216 miles in 4 hours. What is his rate in miles per hour? What we would usually do to find miles per hour is do miles divided by hours. And we can still do that to check our answer, but it specifically asks for us to use a double number line diagram to show our work. Remember, double number line diagrams are just two number lines. All number lines start at 0 or have 0 in the middle if it has negatives. One of them is going to represent miles. The other one is going to represent hours. Over on this side, so on this side we put our zeros, on this side we put our totals. Max traveled a total of 216 miles, put that on the miles number line, in 4 hours, put that on the hours number line. Since we're trying to find the miles per hour, we want to know how many miles in 1 hour. So what we're looking for is whatever number of hours would go above the 1. I'm sorry, whatever number of miles would go above 1 hour. Remember, when we're using double number line diagrams, whatever you do to the bottom or the top, you have to do to the opposite. So if you do something to the bottom, you have to do the same thing to the top. To get this 4 to become a 1, we divide by 4. So we're going to have to do the same thing on the top. We're going to have to divide 216 miles divided by 4. When we do that, it gives us an answer of 54. So if Max goes 216 miles in 4 hours, he goes 54 miles in 1 hour, which means he's traveling at 54 miles per hour. Is your answer. So this is the official answer. If you want to check that using a method that you're more familiar with, which is the way we usually do it in class, to find miles per hour, we do miles divided by hours. So 216 divided by 4, which gives us 54 miles per hour. Notice we did 216 divided by 4 here. We did the same thing right here on the top of that double number line diagram to find the answer. Just multiple ways to work every problem. And this is 2 ways to work this one on page 6. This is the one they want though, the double number line diagram. But we checked our work with this other method and it worked great. All right, our next question was page 7, number 3. Page 7, number 3. So I'm going to find my eraser. Page 7, number 3. It takes Jill 2 hours to run 14.5 miles. At this rate, how far could she run in 3 hours? I'm going to set up a ratio of hours to miles. You can also set up a ratio of miles to hours. It really doesn't matter which way you do it, as long as you stay consistent throughout the rest of the problem. So in 2 hours, Jill can run 14.5 miles. We want to know how many miles she can run in 3 hours. We would have to multiply or divide 2 by something to get the number 3, and that's not the easiest thing to do. So instead of using that, just going straight for the answer, our first step is to figure out how many miles she can go in 1 hour. We're going to find her rate, her speed, how many miles she can run per hour, 1 hour. So instead of going to 3, we're going to go to 1. 2 divided by 2 is 1. We divide this side by 2, we have to divide this side by 2. And 14.5 divided by 2 is 7.25, or 7.25. So if she can run 14.5 miles in 2 hours, well, in half the amount of time, she can run half the distance. So in every hour, she's running 7.25 miles. Well, since we know how far she can run in 1 mile, now it's easier to figure out how far she can run in 3 miles. So all we have to do is multiply by 3. 1 times 3 is 3. Whatever we do to this side, we have to do to this side. And 7.25, 7.25 times 3, 7.25 times 3 is 21.75. That means that she can run, this is your answer. You need to show all your work though. Your answer is that she can run 21.75 miles in 3 hours is what it asked. And we can see that here. That's our answer. You can pause it if you need to look at the screen longer. I'm going to keep going. Our next question is on page 8. Page 8, number 7. It takes Dan 32 minutes to complete 2 pages of math homework. At this rate, how many pages does he complete in 200 minutes? Okay, I'm going to set up, again, another ratio. It's asking you at this rate. So at this same speed, if this same speed continues, we can set up a ratio of minutes to pages or pages to minutes. I'm going to do pages to minutes this time. Doesn't matter which way you do it, as long as you stay consistent throughout the problem. So he can read at a rate of 2 pages every 32 minutes. Oh, not read at a rate. Do math at a rate of 2 pages for every 32 minutes. How many pages can he complete in 200 minutes? So it's asking about 200 minutes, not 200 pages. So what we want is to make this 32 become a 200, and that's also not going to be very easy. If we want to know what we can multiply 32 by to get 200, we can use a calculator. We can do 200 divided by 32. I got 6.25. That means that 32 times 6.25, or 6 1/4, should give me 200. Now I'm going to test that in my calculator, make sure I was thinking straight. Okay, 32 times 6.25, 200. It worked. So if I can multiply this side by 6.25 to get 200 minutes, then I can multiply this side by 6.25 to get how many pages he could read in that amount of minutes. 2 times 6.25 is 12.5, or 12.50. So, in 200 minutes, the answer is that he can read 12.5 pages of math homework. Usually when they do page problems, it's reading rates, math rates, 12.5 pages of math for 200 minutes. Again, if you need to go back and rewatch me work that problem, you can rewind. If you need to look at it a little bit longer, you can pause. I'm moving on. We're still going to be on page 8, but now we're going to look at number 11. To work number 11, you have to work number 10. So that's a little problematic there. So number 10 slash number 11. So number 10 says, Talon buys 5 ounces of tea leaves for $2.35. At this rate, how much money does she need to buy 12 ounces of tea leaves? I'm going to set up a ratio. So this here's number 10 over here. Set up a ratio of ounces to dollars, our amount of money. Okay, which is going to be 5 ounces to $2.35. We want to know how much money does she need to buy 12 ounces. Just like we did in the previous problem, it's not going to be easy to, in your head, think, what can I multiply 5 by to get 12? So you can use your calculator to figure out what you can multiply 5 by to get 12. You can do 12 divided by 5, which is 2.4. That means 5 times 2.4. Oh, that's too small for you to read. 5 times 2.4 can give you 12. So we have to multiply this other side by 2.4 as well. Calculator, 2.4 times 2.35. That is $5.64. Now, nobody actually asked about this problem, so I hope you actually got it right. The answer to number 10 is $5.64. Now, number 11 says, in problem 10, how would your work be different if you were asked how many ounces of tea leaves Talon could buy with $10? So, number 11, we have the exact same information.
as number 10. The exact same basic information. And the same basic information is that 5 ounces costs $2.35. Now, in number 10, it asked how much money would 12 ounces cost, so we put a 12 underneath ounces and found our answer on the other side. But in number 11, it's asking a different question. It's not asking you for ounces, it's asking you for money. Or it doesn't give you ounces, it gives you money. So it wants to know how many ounces she can buy with $10. Well, one of the first changes is it gives you a different piece of information. This time it gives you money. So the right-hand side instead of the left-hand side over here. And instead of figuring out what 5 is going to be multiplied, you're going to figure out what 2.35 is going to be multiplied to get 10. And that's not something we can do in our heads. So we're going to do 10 divided by 2.35. Whoa! Another huge difference doing this problem this way makes is that now we've got this crazy repeating decimal. 10 divided by 2.35, I'm going to try that again, make sure I didn't do that wrong, is 4.255319115. Not pretty. Not a pretty number whatsoever. But that's what we have to multiply 2.35 by. To get 10. So that's what we're going to have to multiply the 5 by to get the answer on this side. So it just makes the problem a lot more complicated. I still have it typed on my calculator, so I'm just going to type times 5 to get what goes here. Because I'm multiplying by this over here as well. I just don't want to write the whole thing again. So we get 21.2765957. Ew. So we're probably going to round this. Let's say we want to buy a whole ounce. Okay, we can afford 21 ounces. So the problem changed a lot. So over here, it said how much money would it take to buy 12 ounces. Over here, it says how many ounces can you buy with $10. It also changed because we had this repeating decimal that gave us an approximate, well, this is a specific answer, but we had to round to get an approximate answer. So there's just some differences that happened there. I hope that explains things. All right. Moving on. Our next question is on page 10. We're going to be doing page 10, number 7. It says describe 2 different ways you could change the values in the table so that the answer to problem 6 is different. So really, again, we're going to have to do 2 problems. This is problems 6 and 7. On this side, I'll do number 6. On this side, I will do number 7. All right. The table shows the price of 2 cereal brands and the number of ounces per box. Which is the better price per ounce? So for each of these, we're trying to find the price per ounce. So brand A. Keep in mind, to find price per ounce, we do price divided by ounces. I'm going to write that up here. Price divided by ounces. to find price per ounce. So brand A, the price is $2.50. We're going to divide that by 18 ounces. Handy dandy calculator. 2.50 divided by 18. That's 0.13888888888. So that's approximately, rounding to the nearest hundredth, because money is always rounded to the nearest hundredth, approximately 14 cents, or 0.14. Dollar sign. Not the cent symbol, dollar sign. Alright. Brand B, find their price per ounce. We do the price, which is $3.50, divided by the number of ounces, which is 24. That gives us 0.1458, which is actually going to round up to 15 cents. So brand A is approximately 14 cents a pound, an ounce, and brand B is approximately 15 cents an ounce. The question said, which has the better price per ounce? The better price per ounce is the cheapest price per ounce, which is brand A. All right, number 7 says, describe 2 different ways you could change the values in the table so the answer to problem 6 is different. So for the answer to problem 6 to be different, that means brand B would have to be the better brand. So how can we change the numbers in the table so that brand B is actually the cheaper brand? There are 2 ways to do that. For brand B to have a cheaper price per ounce, you could either make this number bigger. For instance, 30 ounces is only $3.50. Or you could make this number, the cost, smaller. For instance, it could be 24 ounces for $3.20. If you make this one much bigger, or you make this one much smaller, then your price per ounce will be cheaper than 15 cents, which will either be competitive with 14 cents or be cheaper than 14 cents and have a better answer. Okay? Thinking the other way around as well, you can make this number smaller and or this price bigger, which would make brand A more expensive, which would still change our answers for number 6 to brand B being the cheaper one. So you can either make brand B cheaper by changing these numbers, cheaper per ounce, or you can make brand A more expensive by changing these numbers. There are tons, infinite amounts of numbers you guys could choose to put in there to change this so that brand B is actually the cheaper brand. An example could be, like I said earlier, We could throw a few more ounces in there. Let's say 26 ounces for $3.50. If I do that math, 26 divided by 350. Oops. I did that the wrong direction. I have to do the price divided by the number of ounces. So price, 350, divided by the number of ounces, which is 26. That would be 13 cents per ounce. See, now brand B is the cheaper one because we made a change. So that would change the answer to number 6. You can't use the same one that I used. Make up your own. All right. Moving on to page 12, number 5. Jason runs 440 yards in 75 seconds. At this rate, how many minutes does it take him to run a mile? In the note there, it says that 1 mile is 1,760 yards. Wow. So, I'm going to set up the ratio of yards to seconds. That's 440 yards in 75 seconds. We want to know how many minutes does it take him to run a mile. Well, first, before we can, you guys notice that we're going to be changing yards to miles and seconds to minutes. We have 2 units that have to change in this problem. So it's going to be a very multi-step problem. It's going to be easier to figure out yards to miles first because we have that conversion rate right here. 1 mile is 1,760 yards. So all we have to do is write 1,760 yards. Figure out what we have to do to 440 to make it 1,760. We can do 1,760 divided by 440. It's 4. So it reasons that 440 times 4 is 1,760. I'm going to check that. 440 times 4. It works. So I can multiply this side by 4 as well. 75 times 4 is 300. So, since 1,760 yards is 1 mile, this is 1 mile in 300 seconds. We can convert 300 seconds to minutes. There are 60 seconds in 1 minute. So we can do 300 divided by 60 to convert this 300 seconds to minutes. 300 divided by 60. So 300 seconds is the exact same as 5 minutes. So it would take 5 minutes for Jason to run 1 mile. Jason is an extremely fast runner. Extremely fast. Okay. Still on page 12, the next problem is number 8. It says, for every 140 feet that Kelly rides her bicycle, the wheels turn 20 times. About how many times do the wheels turn in 5 miles? All right, so we have 140 feet. I'm going to set that up as a ratio to 20 turns. 140 feet to 20 turns. We want to know how many turns would happen in 5 miles. So we're going to have to convert feet to miles, but this side is going to stay turns, so that's helpful. We only have to convert one side, which is converting these feet to miles. It helps that it gives us a lovely conversion rate. There are 5,280 feet in 1 mile. So all we have to do is figure out how many times we have to multiply 140 by to get 5,280. 5,280 divided by 140. That is not pretty. Oh, let's try that again. All right, it is pretty. It's 132. So 140 times 132 equals 5,280. If it's 132 times the amount of feet, it's 132 times the amount of turns. So we're going to do times 132 over here as well. 132 times 20 is 2,640 turns. You might think, oh, yay, we're done. It's over. Hold up. 5,280 feet is only 1 mile. You can replace 5,280 feet with 1 mile because that's what it is. So 1 mile is 2,640 turns. If it asked for 1 mile, then that would be your answer. But unfortunately, it asked for 5 miles. How many times will the wheels turn in 5 miles? So you have to take your 1 mile and do times 5 to get 5 miles. So you do times 5 over here. 2,640 times 5 is 13,200 turns. Okay, the next problem page was page 15. I figure the percent section is probably going to be one of the hardest sections for us. We are now on page 15. Number 4. Now, here's a reminder that I taught you guys this year. To find percent of a number, you do the percent times the number. Okay, so it says 5% of what number is 12? 5% of what number is 12? So some number got multiplied by 5%. Now we have to remember how we write 5%. 5% means 5 hundredths. So it's 0.05 times something gives us 12. Now, we did work on solving one-step equations this year. We could write this as a one-step equation. Let's say it's times n. Okay, this is multiplication. 5% times n equals 12. How do we solve this equation? To undo multiplication, we use division. So we're going to divide both sides of the equation by 0.05, or 5 100ths. 5 hundredths divided by 5 hundredths is 1, so we just get 1n, which is just n. So the unknown number is, and 12 divided by 5 hundredths is 240. Now I want to check that answer and make sure it works. So I'm going to come back up here. I'm going to write 0.05 or 5% of 240 is, I'm going to type that in my calculator, 5% times 240 is 12. So that number is 240. That is the one number, if you take 5% of it, it will give you 12. This is kind of complicated stuff. But it's also really cool once you get the hang of it. And to help you get the hang of it, I'm going to do 2 more of these problems. I know that you guys asked for number 4, 5, 6, 7, 9, 10, and 11. But that is a lot. I know it's a lot of work for you guys to do, but I feel like once I work about 3 of these, you should get the hang of it, okay? So again, we're doing another problem from page 15. This time, we're doing number 6. Let's do number 6. Following the same pattern as before, 70% of what number is 56? Just means 70%, which is 70 hundredths, which is 7 tenths, of is times something, gives us 56. We solve this equation by dividing both sides by the percent. So we're going to do 56 divided by 7%. So this side of the equation gets divided by 7%. This side of the equation gets divided by 7%. We get n equals 56 divided by 7 tenths, 70%, is 80. You check to make sure this works. 70% of 80 is 56. Well, let's see. Let's try it here. is 0.7 times 80 equal to 56? 0.7 times 80. It is equal to 56. So this does work. This is the correct answer. Yay, us. Next I'll do number 9. Still page 15. Number 9. 85% of what number is 102? So 85 hundredths times what number equals 102? If you haven't figured out the pattern yet, we're going to do 102 divided by the percent. That's the pattern. You take your final answer number and you divide by what you're multiplying by over here to get your final answer. So 102 divided by 0.85. We get that the number is 120. That seems tricky because it looks like a lot like our 102. Let's check to see if it works. Let's see if 85 hundredths times 120 equals 102. Okay? 85 hundredths times 120 is 102. It checks out. This is the correct answer. Okay. Now, page 15, number 11. This question is really just trying to make you think about what you've been doing on the rest of this page. It says, explain how you could use 25% of a number to find the number. So, if you knew that 25% of a number was Sandra. Okay, we're just pretending that this is a number. Any number, doesn't matter what it is. Explain how you could use this 25% of the number to find this number. Well, it's the same thing you've been doing on all the rest of the problems. Remember that pattern I said we were doing? You would take whatever number this is, which I have aptly named Sandra, and you would divide by the percent, or in this case, 25% or 25 hundredths. Now you're going to need to write that in words. This is a explain how, okay? I'm just trying to show you what you're doing. So basically your answer is whatever the percent of the number is, you would divide that by 25% or 25 hundredths to figure out what the original number was to start with. All right, moving on to page 16. Page 16, number 1. It says, complete the bar model to show how many 1/5 make 14/10. It shows you that this is 1/5. Okay? And that's probably the part that's confusing you if you're confused. Why would it have two things labeled as 1/5? Well, if two of them makes 1/5, half of a fifth is 1/10. So that means this is 1/10, and this is 1/10. 2/10 simplifies to 1/5. 2/10 is the same size as 1/5. So it wants us to complete the bar model to show how many 1/5 make 14/10. So you need 14 of these. Well, every pair of them makes a 1/5, right? So we need 14 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oh no, I'm running out of room, 13. Oh, perfect, 14. So I've modeled 14/10. Now I just need to model how many fifths that is. Each pair of them is 1/5. You can just draw like a line. That's 1/5. That's 1/5. This pair makes 1/5. This pair makes 1/5. This pair makes a fifth. And this pair makes a fifth. How many fifths is that? 1, 2, 3, 4, 5, 6, 7. They wanted to know how many fifths it was, so I would write one big bracket as well, just how they did on the top one, and say that's 7/5. Notice that it's half as many tenths, just like we started. Each half of 1/5 was 1/10. So 14/10 is the same as 7/5. We also know that because we can divide both the 14 and the 10 by 2 to get 7/5. All right, the next page that was asked about was page 25. Page 25. The person that asked for page 25 did not specify a number. So we're just going to talk about the skill in general. Okay. It says, check each answer to see whether the student evaluated the expression correctly. Guys, that means did they follow the order of operations? On the top of page 25, write the words order of operations. That's the biggest deal on this page. Order of operations is a super big deal here. It says, if the answer is incorrect, cross out the answer and write the correct answer. So on this side, we're going to do number 2, okay? On this side, I'm going to write the student answer from your paper. On this side, I'm going to work it the correct way, okay? So number 2 says 8 times x plus 2 when x equals 6. So you're going to plug in using substitution. If x is 6, you can replace the x with a 6. So that's 8 times 6 plus 2. The student on your paper wrote that. They said 8 times 6 plus 2. Then they wrote that equals 48 plus 2, which equals 50. That's what they think the answer is. Now we're going to work it ourselves and see if we agree with that. 8 times 6 plus 2. Let's think about the order of operations. Order of operations is penned as P stands for parentheses or grouping. We have that. We have to do what is inside the parentheses first. That means we have to add 6 plus 2 before we can multiply by 8. 6 plus 2 is 8, actually. So we should have this 8, and this is multiplied. When you have a number bumped up to a parentheses, it implies multiplication. So this is 8 times 6 plus 2, which is also 8. And 8 plus 8, not the plus, 8 times 8 is 64. So the correct answer should be 64. If we come over here and look at what the other student wrote, that's not what they did. They didn't do it right. They multiplied first. They forgot the order of operations. They did 6 times 8. If they had they could have added first like we did, or they could have applied the distributive property. They could have done 8 times 6 is 48, and 8 times 2 is 16, and added those together to get 64. But if you want to multiply first, you have to multiply. If you want to multiply first, you have to multiply to both of the numbers. If you're not going to use the distributive property, then you need to follow the order of operations. So it says to cross out the answer that the other kid wrote if it's wrong, and write your own answer. See, I've got his answer crossed out, and then show your work over here. I hope that answers your question. Cool beans. If you guys have, after watching this video, if you have any more questions on this same page, you can ask more, okay? Just specify a problem. This one was number 2. I'll do whichever other ones you need, okay? Same thing with number 27. Number 27, or page 27, I'm sorry. Page 27 is not necessarily an order of operations problem anymore. Nope. Page 27. We'll do number 1 first. It says, determine whether each pair of expressions is equivalent. Show your work. The first expression is 2 times x minus y. The second expression is 2x minus 2y. We want to figure out if these are equal to each other or not. Okay? They're equivalent. I'm looking at this one, and I see that if I wanted to, I could apply the distributive property because it's a group being multiplied by an outside number. So I could do 2 times both of these inside numbers. 2 times x is 2x minus 2 times y is 2y. Well, looky there. 2x minus 2y, these are the same thing, just written in a different way. So you write, yes, these are equivalent. That's your answer, equivalent. Show your work, though. Let's do page 27, number 3. One of them is 4p plus 3c, and the other is c plus 2p times 2. This one's the one that can be distributed. C plus 2p times 2, I'm going to write that a bit easier way. It's the same as saying 2 times c plus 2p. You can move the times 2 to the front. That's the commutative property of multiplication. You can multiply in whatever order you want. You can do this group times this group, or flip it around so it's the 2 first and then that group. I'm going to distribute the 2. 2 times c is 2c, plus 2 times 2p is 4p. Well, it looks like we got the 4p part right, but this says 3c, and this is only 2c's. So these are not equivalent. And that's your answer. You write that they're not equivalent. I hope that helps. Let's do number 8 on page 28. Page 28, number 8. We have 2x plus 2x plus 2c plus 6 and 2x plus c plus 3 times 2. Wow. Now, on the previous page, only one of the expressions could really be simplified to see if they were the same. On this side, on this page, both of these can be simplified. So let's simplify them both, see if they end up being the same answer. Over here, we have some like terms we can combine. 2x can be added to 2x because they have the same variable. If I have 2 x's and then I get 2 more x's, now I have 4 x's. So this is 4x plus 2c plus 6. Now that can't get any simpler anymore. Just bring the 2c down and I bring the 6 down. No more of these can be combined. Okay, this is in the simplest form. We cannot add the 6 to anything because it doesn't have a c on it and it doesn't have an x on it. Now over here, again we're multiplying by an outside 2. I'm going to switch these groups. I'm going to put the 2 first and then the big group second. So we have 2 times 2x plus c plus 3. So everything in this group is being multiplied times 2. So 2 times 2x is 4x plus 2 times c is 2c plus 2 times 3 is 6. These all have the exact same terms. So these are equivalent. Now, we're also going to do number 11. I'm not going to erase the board though, because number 11 asks, how can you check your answer to problem 8 by choosing values for the variables? So, it's basically if you pick a value for x, let's say 2, x could be 2, pick a value for c, C can be 5. Those are easy numbers. We're going to check to see if these are actually equivalent, like we discovered in number 8, by plugging in these numbers back into our original expressions. Okay, so this is 2 times x, which we say is 2, plus 2 times x, which we also say is 2, plus 2 times c, which we said will be 5, plus 6. Order of operations, we have to do all of our, all we have right now is multiplication and addition. So we have to do all of our multiplication before we can do any of our addition. So our multiplication from left to right is 2 times 2 is 4, plus 2 times 2 is 4 again, plus 2 times 5 is 10, plus 6. Now we can add everything up. 4 plus 4 is 8, plus 10 is 18, plus 6 is 24. Now we have to do the other side. If it's also 24, then it is, we've checked our answer, it's equivalent. If it's not also 24, then we made a mistake either checking it or in our original evaluation. So over here we have 2 times x, which is 2, plus c, which is 5, plus 3, all times 2. So, order of operations. P is for parentheses. We have to do everything inside parentheses first. So let's look. Inside this set of parentheses, we have multiplication and addition. The multiplication comes first, PEMDAS, and comes before addition. Multiplication comes before addition always. 2 times 2 is 4. So we have 4 plus 5 plus 3, all times 2. Again, we still have to finish everything that is inside this parentheses before we can do times 2. 4 plus 5 plus 3, 5 plus 4 is 9, plus 3 is 12. So this is 12 times 2, which is 24. We've checked. We now can see numerically that these are equivalent. They give us the same answer if we plug in numbers. All right, next is page 30, number 6. On Saturday, 45% of the music Brianna listened to was country songs. She listened to 27 country songs on Saturday. How many songs did Brianna listen to on Saturday? So, just like we practiced earlier, 45% of the total amount of music equaled country songs. So 45% of all the music she listened to was country songs. I'm just reading the problem and writing down what I know. She listened to 27 country songs. So we can actually replace the word country with 27. So, to figure out how many total songs she listened to on Saturday, we need to figure out 45% of what number equals 27, which is 45 hundredths times what number, we'll do N for music this time, equals 27. we solve multiplication equations. We solve multiplication equations using the inverse operation of multiplication, which is division. We're going to divide this side of the equation by 45%, aka 4,500, and divide this side of the equation by 4,500. 4,500 divided by 4,500 is 1m, which is just m. And then 27 divided by 4,500 is 60. Now remember, it's always good to check your answer. 45% of 60 equal to 27. Let's see. 0.45 times 60 equals 27. So the check is good. This is the answer. 60 songs. 60 total songs. And I believe that's it.
Thanks for watching the video. I hope this helped you guys out some. I will take requests for what problems you still need me to help with for the next video. I'll make another one, okay? So if you have any more questions after watching this video, or because you watched this video, you know, maybe you worked a page and you thought you did it all right, but I worked a problem and I got a way different answer than you did. You probably need to check your answers on that whole page, maybe even that whole section, okay? So use this, what we did together, as a way to check yourself on the problems that you've done, okay? And if you want to check any other questions, or if you need any more questions answered, send me those, the page number and the number, problem number. I miss you guys. I miss you guys a lot. I'm going to stop rambling now.